Humans have been thinking about space and its properties for thousands of years. It is not for nothing that geography is sometimes called the mother of all sciences. The English physician of the Victorian period, John Snow, is often credited with one of the first uses of formal spatial analyses. During the 1854 London cholera epidemic, he mapped households with infected patients and, through the resulting cartographic and statistical study, Snow was able to identify a contaminated street corner water pump as the likely source for the local outbreak. Now, modern spatial analysis is incredibly multidisciplinary and has a wide range of applications in digital humanities and social sciences for creating new information and for solving problems. We use it to understand the physical world around us, to study where things are and why they are there, to identify meaningful patterns and to make predictions based on them. For instance, spatial analysis allows us to describe and investigate entities using their locational and attribute characteristics. So here we have laid out the landscape of medieval villages and towns in eastern England. To the naked eye, their comparative densities in many places seem fairly consistent. But by calculating a mathematical surface, and by weighing it with data drawn from historical tax assessments, we can create a density model for the varying distribution of wealth during the Middle Ages and represent it as a kind of a heat map. This gives us a starting point in thinking about economic activity in different regions. A visual inspection of points on a map can be misleading, however, not the least because the human brain is geared towards pattern recognition. We may simply invent patterns in the data because we expect to see them there. So let's say that we are interested in studying the importance of trade and transportation to the growth of towns and commerce. Can we establish a quantifiable connection between navigable rivers and historical commercial sites such as markets and fairs? Well, we can test distributional patterns by the use of various techniques in spatial statistics and pattern analysis that examine the relationships between objects and events. By creating hundreds or thousands of random site locations and calculating their distance to the nearest river in a spatial probability simulation, for example, we can determine that there is a real spatial relationship between the actual locations of early commercial centers and historically navigable rivers. This gives us information about the economic underpinnings for the flowering of Western European cities. Now, such approaches can be applied in many different fields and disciplines to different kinds of data. This also means that methods and solutions developed in one field of study can be quickly applied by another, further enriching the possibilities that spatial analysis has to offer to science and the humanities.